Let's talk about the TypeScript binder. For more background, you're probably going to want to start with Orta's How the TypeScript Compiles video that covers the entire compiler at a higher level. I'm just going to talk about the binder here and not talk about any of the rest of the compiler. I'm going to start with background to sort of what a binder does and how it does it. And then the architecture will sort of delve into some of the details of how it does its thing. So background, what is a binder? A binder records which names are declared and where. And the basic feature this unlocks is go to definition. If you have an identifier, the table that the binder is building lets you look up where the identifier is declared. So say you have welcome in this function call here. The binder will say, oh yeah, you can find it here. You have message, you can find it here. And the way it does this is by building these tables. And these are just maps of strings to declarations. So let's walk through and see how it actually works. So in this first statement, const message equals hello world, that's a declaration. So the binder will put MSG into the global scope, and it'll map the string MSG to this node here. That's a declaration node. The next statement you hit was going to be welcome message. That's a function call, not a declaration, so nothing happens, just skipped. The next statement is function welcome, which is a declaration. So the string welcome maps to this node in the parse tree. Then the binder is going to walk into the function because it's going to walk the entire parse tree eventually. And we'll see that str is a parameter, that's a declaration. But we're now inside of the scope of function welcome. So it creates a new binder, a new map, adds str and maps that to the parameter declaration here. And then you've got console.log string, function call, not a declaration, just gets skipped. And if there was something in the body here, that would also go into the map for welcome. Then given this set of maps, by the time you're done walking the tree, you can then look up any name you need to. If you're the language server, you're done. You found the declaration, that's what people might want. The checker is probably going to ask more questions like what is the type or what is the inferred type, things like that. But notice actually that the binder didn't actually care about types in this case. All it's doing is finding a declaration. So a JavaScript binder is actually going to look about the same as a TypeScript binder. All it's doing is finding names and sticking them in maps for lookup later. So some more background. What is mini TypeScript? It's a model compiler. It has two models that I wrote. One is micro TypeScript, which is a textbook compiler, sort of the smallest vertical slice of a language I could imagine, like you would find in a textbook. But it's written making some of the choices that TypeScript would make when compiling. But it's still very small. Sent to TypeScript is a 1/100th scale TypeScript compiler. It's supposed to be a miniature TypeScript compiler. Right now it focuses on the checker, so the binder is actually not that much more complicated than micro TypeScript. And we'll look at both of those, plus a short look at the TypeScript types as well, so from the full compiler. All right, so let's look at that now. Okay, so just to show off what a small slice of the language is, here's all the different kinds of nodes we have. We have identifiers, literals, which are all actually just numbers, assignments, statements, vars, and type aliases. So the only legal programs in this language are things like vars, assignments, and type aliases. That's your language right there. So it's very, very simple. All right, so let's look at the actual types for symbols and binding and so on. Okay, so the nodes, the node at the top of the tree is going to be called module. That's a type of source file, and source files, of course, have statements. That's a list of statements, but it also has a table called locals. And a table is just a map of string to symbol. So this is the map that I was telling you about that binders build. A symbol then is just a list of declarations plus a special declaration called value declaration. And in TypeScript, we have to keep a list of declarations around because you can have, say, var x equals 1, and this is actually legal code. You shouldn't write this, but you can. And of course you can have type x equals number. You can have any number of declarations of various kinds. Some other languages would probably only have like value declaration here, and then a property called type declaration, because you can have var x and type x. Some languages might only have just declaration, because you couldn't actually have a var x and a type x. All right, so that's the types. Let's look at the actual binder now. So the binder, like I said, takes a module, starts walking over its statements. It's going to walk over the entire tree, but of course in this language there's not much to walk, so it's like pretty much just one function. And that function basically checks to see if you're looking at a declaration kind of node, and if you are, it binds it, otherwise it just skips it. So like assignments are skipped here. And what it first does is actually check to see whether the thing has been bound already or not. And if it has, then you might actually end up with a duplicate declaration error. If it hasn't, it just creates a new symbol. So actually, let's look at that check here. So if you do find the symbol, the binder is going to look in the list of declarations for the symbol that it found for one with the same kind. So in other words, remember, you can write this. This is fine. But in this language, actually, we don't do the JavaScript thing. This is illegal if you have a var x. So when you're binding these three things, var x is going to be fine. It's going to use this code path here. Type x is going to be fine. It's going to use this code path here. And then var x here is going to say, it's going to look at the existing list of declarations and it will find one that has the same kind, this one, and then we'll issue an error that you have a duplicate declaration. And that's basically binding right there. You just stick things in maps and there's a bit of error handling. Resolution is pretty simple too. You pass in the table that you want to resolve from, the name you're looking for, and then whether you're looking for a var or a type alias. And this is called meaning because you're basically asking whether you're looking for a value or a type. And you can always tell syntactically which one you're looking for. So if you have var x equals, or var y(x) equals 1, then this is a type. Then if you're right here, then you're looking for a value. So yeah, we can actually see that. In fact, here, when we look for identifiers, resolution passes var because it's looking for a value. And when you're checking types in the checker, it's going to try to resolve a type alias. All right, so that's basically how binders work. The smallest possible binder anyway. So let's talk about some sort of concepts used for architecture. There's some definitions. I'm not going to talk about these too much, but if you want to look up the PowerPoint later, then I'll link to it and you can read this later. So a name is just a name for a variable type or namespace. A node is a building block of a syntax tree. An identifier is a node that is a name. So when you say x plus 1, x is an identifier. A declaration is a node that declares a variable type or namespace, so like var x, and it has some other info in addition to the name, like the initial value, its type, its types properties. That's the sort of thing a checker might want to look up. A symbol is just a collection of declarations. A symbol table is a map of names to symbols. And name resolution is a process where when you give an identifier and the meaning you're interested in, you walk up the syntax tree looking for symbol tables that have a matching name and meaning. So that's the resolve function I showed you earlier. It returns a symbol. Finding a meaning is whether a symbol has a declaration of a particular kind. That's the find call that I showed earlier, and we'll go back to that. Okay, so let's look at the Typescript binder and checker. So let's go back here. Let's just check out the other branch. Okay, let's take a quick look at the types. You can see the language is now quite a bit bigger, but our types haven't changed much for symbols. So table is still a map of string to symbol. Module is still local in the statements, plus a kind. And symbol is still just a list of declarations plus a value declaration. and then it has some caching for the checker, but that's unrelated. The only real new thing is that meaning is now an enum for value and type. So we're not directly using var and type alias anymore because there's multiple kinds of value declarations. There's like varlet and const in this language, I believe. So let's look at binding now. So the walk is now much, much bigger, but the core is still find something like var, declare symbol. And declare symbol is pretty much the same code. You still check your container, and if you find a symbol, you might issue a duplicate declaration. And if you don't, then you push the new declaration onto the list. It's pretty much the same. The only real difference is that, sorry, actually, it is pretty much the same. Yeah, the checker is a little bit different. Let me show you that. So here we go. So the resolve function no longer directly takes a table anymore. Instead, it looks up the table. So you've got this loop here, while location equals location.parent. That will start at some node, the thing you're trying to resolve, like some identifier somewhere, and it will walk up the tree toward the root. And that's going to find nodes that have a particular kind of scope. So if you have a module, a function, a signature, which is like a type of a function, those all have locals tables, and object literals have members. If you find one of those, then you have a table, and you call getSymbol, and getSymbol is just .get off a map. Pretty simple. The one thing you do is you confirm that the meaning you pass in, either type or value again, matches one of the meanings on the symbols, and you have to look at all the declarations in a row to find if any of them matches, say, type that you're looking for. All right, so that's not actually that much more complicated. So let's talk about one more thing that we have to look at the real TypeScript compiler for, and that's symbol flags. So symbol flags quickly tell you whether a particular symbol matches the meaning you're looking for. This is an optimization, really, but it's kind of interesting, and if you are reading the real TypeScript binder, you probably want to know about this because it's confusing at first, and it's sort of a subtle implementation. Basically, that lets us not iterate over the declaration list each time. You just, as you're binding, use bit flags to calculate ahead of time what kinds of declarations are on there. So let's show that off. All right, so let's open up real TypeScript. So we've got this enum symbol flags, and you can see actually it's huge, and it's a much finer grain than just type or value. So we've got functions, classes, interfaces, and it's using bit flags here. So the way you would use this is something like if x.flags, come on, compile it. Okay. Oh, that's actually good, compile it, thanks. So this is just made up code, obviously it's not right, but you say if satisfied.flags and symbol flags.class, then do something. And so you can quickly tell if you have a class, which is super useful if you're writing, say, code to check a class. You can quickly reject anything else and issue an error. And as you can see, there's tons of stuff. Methods, constructors, object literals, type literals, get and set accessors, just sort of everything in the language. It has its own entry in the bit flag enum here. So how do you quickly tell if you have a value? Well, value is actually kind of interesting. This is a union here. So yeah, value is a union of all of these things. And so when you say and symbol flags.value, you're looking at a bit mask. And if the bit mask returns true, then you do your thing. And so there's a lot of these. I mean, there's some fancy ones like accessor equals get or set accessor, but the most useful ones are type and value. So here's type, all the different kinds of type declarations, and value, all the different kinds of value declarations. So that quickly lets you figure out if you have a type or a value without having to iterate over the declaration list. So there's one more thing. We already did demo for the TypeScript. So symbol flags are also used for excludes. So this is an odd thing that you mostly need because TypeScript is a weird language. Again, remember I talked about TypeScript allows merges of various things, and you can have types that have the same name as variables and so on. So excludes quickly tell us if we have a duplicate declaration error. So say we have function f with a, b, a. So there should be a duplicate declaration error on a because we have it declared twice. Inside the body, then we have type b equals number. We shouldn't have one there because b is a type, and over here it's a value. So if we have declare, say we're calling declare symbol, we're going to start passing it three things: the name we're trying to bind, the symbol flag that it is, so it's a parameter here, and then something called excludes. So excludes here is value. And the initial time you need to bind a, value doesn't actually do anything. Excludes doesn't do anything because nothing's been bound yet. It only really happens when you have your second call. So the first time we set a's flags to parameter. B's flags get set to parameter. Remember that's a bit on a bit mask basically. The second time we try to declare a, we say that we need to declare parameter, but we're excluding values. And so what we do is we check a's existing flags. Remember that's a parameter. And we'll see that a.flags and values equal 1, and we'll note it issue in a duplicate declaration. So let me see if I can show you that. So remember, yeah, value is here in parameter. Oh, is it property? Sorry, it's function scoped variable, not parameter. The slides are slightly wrong. So function scoped variable is part of variable, which is then part of value. Right. So the bit mask over here will finally return 1, in which case you know immediately to return a duplicate declaration. But when you declare B with a type, you say, oh, this is a type alias. And it can't merge with any other type. But merging with values is fine. So we check b.flags. B.flags will be function scoped variable. And when you bit mask that against type, it doesn't match. It's just the answer is 0, so you're fine. So you say, okay, b.flags or equals type alias. So next time you see type B in the same scope, you will issue a duplicate declaration error because type aliases are not allowed to merge with type aliases. So there's some really interesting excludes here, like parameter excludes, the ones we just looked at. It can't merge with any other value. Property excludes can merge with any other value. I'm not sure why that's the case. There's some here that I don't really understand. Function excludes. Functions can't merge with any other value, but they can merge with functions or namespaces. That's value modules, old weird names for namespace. And classes. So you can merge with classes and apparently other functions, which is odd. Interfaces can't merge with other types, but they can't except for interfaces and classes. So see, we're using binary negation here to allow in a couple of things that can merge with interfaces. And so values, methods can't merge with any other value, but they can merge with methods. Gets can merge with no other value except for sets, and sets can merge with no other value except for gets. That would actually make sense. And so on. Well, actually, that's about all of them. But excludes are kind of even trickier and even more of a corner case in the compiler, but they're also pretty interesting to look at. All right, and that's the binder. We talked about some kind of interesting corner cases here at the end, but the basic idea of the binder is that it's just looking for names and putting them in maps and recording the declarations. It's not actually that complicated of a component. All right, thanks for watching.